Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the formulas for combinations and permutations. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video. We will cover the following topics: factorials, formulas for combinations and permutations, and why these formulas work. Note, prior to this presentation, Mrs. Borlaug's students have already done counting word problems and used the calculators to evaluate NCR and NPR. This presentation is designed to show them how to evaluate combinations and permutations using the factorials. Topic 1 is factorials. In looking at factorials, we're going to look for a pattern. In 1 factorial, we have just 1. 2 factorial is 2 times 1, which gives us 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. And 6 factorial is left as a student exercise. Well, let's go on and give you. It would be 6 times 5 times 4 times 3 times 2 times 1, and would equal 720. Do you see the pattern? We start with the number given and multiply all whole numbers, all counting numbers, down to 1. The only weird one is 0. We know that 0 can act differently in mathematics. When we multiply by 0, we get 0. And 2 to the 0 is actually 1. 0 factorial is kind of defined that way as well. It's defined to be equal to 1 as well. So here's the summary of what we've covered so far. 0 factorial is defined as 1. 1 factorial is just 1. 2 factorial is 2 times 1, and then our pattern falls from there. And 0 doesn't kind of fit into our pattern, but everything else does. And 0 is kind of like the absence of all factors, and if we have no factors, 1 is a factor of like everything. So it kind of fits there. Topic 2. Our next topic is the way to find combinations and permutations using our formulas. Now, we can do these on our calculator, and if your teacher is not going to test you on doing these by hand, you probably don't need to watch this video. But if doing these by hand will be part of your test, then you do need to watch this video. So some of your teachers will want you to be able to show that you know and understand the formulas for doing these two concepts, as well as typing them into the calculator. So we will look for our pattern and then develop the formula. Permutations. We're going to do 100, pick 3, and that would, or a permutation of 3, and that would be 100 factorial over 97 factorial. 45p4, which is 45 over 40 factorial. 45 factorial over 41 factorial. 78 p5, which would be 78 factorial over 73 factorial. And again, we're leaving 19 p7 as a student exercise. So think about what that last one should be. Notice that the top of our fractions seem to be the first number. In the first one we have 100 and 100 is on top. The second one has 45 and 45 factorial is on top. The third one has 78 and 78 is on top. So what would be on the top of the last one? Would be 19 factorial. Now, what would the bottom of our fraction be on that last problem? Well, we have 97 on the bottom of the first one. We have a 3 and 100. Where are we getting 97? Well, we could subtract 100 minus 3 and get 97 factorial. Does that hold true if we do the same procedure for the next problem? 45 minus 4 gives us 41. Yes, it does. 78 minus 5 would give us 73. So the bottom of your student exercise there, the bottom of your fraction would be 19 minus 7 or 12 factorial. In general, our formula is NPR, N being your total, R being the number of selections you're making, is N factorial over the difference between N and R, N minus R, factorial. Now let's do combinations. Again, we're going to look for the pattern. Notice when we have 100 combination 3 or 100C3, we have 100 on top, 97 on the bottom, just like we did before, 100 factorial, 97 factorial, but we've added this 3 factorial on the bottom. 45, 4, 45, 4, and that 41. So the pattern looks pretty obvious here. Obvious is a dangerous word in math. So let's think it through. What would the top of our fraction be for our 19C7? Well, it looks like the top should be 19. What would our bottom be? Well, it looks like we need 2 parts to our bottom. The first part would be the subtraction of 19 minus 7 and be 12 factorial. And then the next part of it would be the 7 factorial itself. In general, NCR has N factorial on top over N minus R factorial, R factorial. So it looks very similar to what we had with just the extra R to the permutations. And this is a great place to stop. I think I had thought I could get this done in one video, but there's not a good place. So I'm going to stop with those 2 formulas, and I will pick up exactly right here when I do the second video on the formulas.